A crankshaft position sensor plays a critical role in engine management. It provides the engine computer with information about crankshaft position and speed, information the computer uses to control important engine functions. That means replacing the sensor is only one part of the diagnosis. A new sensor may fit correctly, look exactly like the original, and still produce a signal that isn't reliable enough for the engine computer to use. And that's where aftermarket sensors can become difficult to diagnose. The problem may not be visible from the outside, and a trouble code alone can't tell you whether the sensor itself is actually defective. So in this video, we're going to look at why an aftermarket crankshaft sensor can fail, what can affect the signal it produces, and how to verify signal integrity before you replace another part. The goal is simple. Don't judge the sensor by whether it's new. Verify what it's actually doing. Is the new sensor actually working? If you've already replaced the crankshaft position sensor and the problem is still there, the next step isn't automatically replacing another part. First, you need to know whether the replacement sensor is actually doing its job. A new sensor may look identical to the original, fit the connector, and bolt into the correct position. But those things only tell you that the sensor fits the vehicle. They don't tell you how the sensor is performing electrically, and that's an important distinction. The engine computer doesn't know or care whether the sensor came out of the box 5 minutes ago. It only sees the electrical signal coming from the sensor. If that signal becomes weak, inconsistent, or drops out, the computer may lose the crankshaft position information it needs to control the engine. That can lead to symptoms such as a no start, intermittent stalling, or a crankshaft position sensor code. So at this point, don't ask whether the sensor is new. Ask whether the sensor has actually been proven to work correctly. And to understand why a new aftermarket sensor might fail that test, we need to look at what can actually go wrong inside the sensor. Why aftermarket sensors can fail. So, what can actually go wrong inside a crankshaft position sensor that looks perfectly normal from the outside? There isn't just one possibility. Inside the sensor, several components have to survive heat, vibration, and constant changes in operating temperature. First, look at what can happen to the internal electrical connections. The connections inside the sensor have to remain reliable through thousands of heat cycles. If an internal connection or solder joint is poorly manufactured, repeated expansion and contraction can eventually cause it to become intermittent. The sensor may work when the engine is cold, then become unreliable as the temperature increases. That can create a problem that seems random, because the sensor may work sometimes and fail at other times. The sensing element itself also plays an important role in how accurately the sensor detects the reluctor. As the reluctor passes the sensing element, the sensor has to detect those changes accurately. If the sensor's internal magnetic or electronic characteristics aren't within the required range, its output may be weaker or less consistent than the engine computer expects. Then there's the sensor housing and its seals. The sensor operates in an environment exposed to engine heat, oil, and moisture. If the seal doesn't properly protect the electrical connection, contamination can eventually reach areas that should remain dry. That can lead to corrosion, increased resistance, or an intermittent electrical connection. And there's another possibility that can be harder to recognize: electrical noise. The crankshaft position signal is an electrical signal that has to be interpreted reliably by the engine computer. Poor sensor construction, wiring, or shielding can make the signal more susceptible to unwanted electrical interference from other systems on the vehicle. So the important point isn't that every aftermarket sensor will have these problems. The point is that a sensor can have an internal or signal quality problem that you simply cannot see by looking at it. It can fit perfectly, it can look brand new, and it can still send a signal that isn't reliable enough for the engine computer. Which brings us to the real issue. How do you determine whether the signal is actually good? The real clue: signal integrity. This is where the diagnosis changes. Up to this point, we've talked about what can go wrong inside the sensor, but none of those problems are necessarily visible from the outside. The sensor can look perfect, the connector can be plugged in, and everything can appear normal, but the engine computer doesn't evaluate the sensor by how it looks. It evaluates the electrical information it receives from that sensor. That's why the signal itself becomes the real clue. A crankshaft position sensor needs to produce a signal that allows the engine computer to accurately determine crankshaft position and speed. That signal has to be consistent with the design of the sensor and the specifications of the vehicle. If the output is weak, intermittent, distorted by excessive electrical noise, or missing when it shouldn't be, the computer may lose the information it needs. And that's when a sensor can appear to be working while still creating a problem. This is also why a trouble code alone isn't enough to condemn the sensor. A crankshaft position code tells you that the computer detected a problem with the signal or its circuit. It doesn't automatically tell you whether the sensor, the wiring, the connector, or another part of the system caused it. Instead of asking, "Is this aftermarket sensor bad?" you can ask a much better question. Is this sensor producing the signal the engine computer expects? That's the answer we're going to verify next. How to verify the signal. Now we can move from suspicion to evidence. The goal isn't simply to find out whether the sensor produces a signal. You need to determine whether that signal is behaving the way this particular vehicle requires. The most powerful tool for doing that is an oscilloscope, connected to the appropriate crankshaft position sensor circuit. An oscilloscope lets you see what the sensor is actually producing while the engine is cranking. And this is where the sensor type matters. A variable reluctance sensor typically produces an analog AC waveform as the reluctor moves past the sensing element. A Hall effect sensor normally produces a digital switching signal between defined voltage levels. So don't expect every crankshaft sensor to produce the same waveform. The important question is, does the waveform match what this sensor and this vehicle are supposed to produce? Look for consistent pulses, unexpected dropouts, missing sections, or abnormal changes that don't match the manufacturer's specifications. For a variable reluctance sensor, you can also measure the AC output while cranking. Compare the measured output with the specification in the factory service information. If the output is significantly below specification, that can indicate a problem with the sensor or its operating conditions. But don't condemn the sensor yet. The air gap, the reluctor, the wiring, and other circuit conditions can also affect the signal. For a Hall effect sensor, the test is different. You need to verify the required power supply and ground. Then check whether the signal switches correctly as the engine rotates. Again, compare the result with the vehicle's specifications. And don't forget the connector and wiring. Look for chafed wires, loose or pushed back terminals, corrosion, oil contamination, or excessive resistance where applicable. A circuit problem can make a perfectly good sensor appear to be defective. Finally, check the physical relationship between the sensor and the reluctor. If the sensor is not the correct application, isn't seated correctly, or the specified air gap is incorrect on a design where air gap is adjustable or specified, the signal can be affected even when the sensor itself is electrically capable of working. So don't judge the sensor by one measurement or simply because it fits the engine. Look at the signal, verify the circuit, check the physical installation, and compare the results with the manufacturer's specifications. That's how you turn a suspicion into evidence. Is the sensor really the problem? Now we can answer the question that started this whole diagnosis. Is the aftermarket crankshaft position sensor actually the problem? If the circuit checks out, the required power and ground are present where applicable, the connector and wiring are in good condition, the sensor is installed correctly, and the physical relationship with the reluctor is within specification, but the sensor still produces an abnormal signal, then the sensor itself becomes a much stronger suspect. That's very different from replacing it simply because a trouble code appeared. But what if the signal looks correct? If the sensor is producing the expected signal, and that signal reaches the engine computer correctly, replacing the sensor again probably won't solve the problem. At that point, The sensor has given us an important answer. The problem is likely somewhere else. There could be a wiring problem, a poor connection, a reluctor or mechanical timing issue, or another engine management problem affecting the symptoms. This is why a trouble code should be treated as a starting point, not a final diagnosis. The code can point you toward the crankshaft position circuit. The test results tell you where to look next, so don't stop at "the sensor is new," and don't jump straight to "the sensor must be bad." Instead, follow the evidence, verify the circuit, verify the signal, compare the results with the correct vehicle specifications. Once those pieces agree, you can make a much more confident decision about whether the aftermarket sensor is actually causing the problem. And that's the real advantage of testing. You don't have to guess. So before you replace that crankshaft sensor again, test it first. Don't guess, verify. Have you ever installed an aftermarket crankshaft sensor that didn't solve the problem? What did you eventually find? Share your experience in the comments.